Yo, so I've now adapted my game to use the new physics system, and that includes different kinds of collision detection algorithms that you can choose between. And I'm just going to show what difference it makes. So in my game, I am spawning 50 pedestrians at random locations that all have collision detection active on them. And also there are around 40 buildings placed around, which makes it about 100 bodies. So I'm just going to show how this runs with the different types of collision detection algorithms. So first I'm going to show the brute force, which is an algorithm that's just a very naive approach by just checking each body against each other body. And let's see how that runs. And you can see we're about 165 FPS, and we get collision detection. Yeah, it all works. Well, almost. Some of these algorithms I haven't really fixed some of the collision issues, but the main point to show here is the FPS difference. So we're on about 165, and this is for 50 bodies. And let's change this to the sweep algorithm. So the sweep I've covered in another video, but it basically sweeps the screen from left to right, and it sort of divides the check, so you don't have to check each body against each other body. So it reduces the complexity a lot. And you can see there's actually no difference in FPS at this point. And that's because there are too few bodies to make a difference here. So yeah, that's the sweep algorithm. And now let's try the quad tree. And the quad tree we also covered in another video. It basically also does like a division type thing. I can actually enable the, well, not that one. Now you see the collision boxes here, but I can enable the quad tree visualization here. So you can see all these boxes, which are dynamically built up. Well, yeah, it's built up each frame, frame by frame. And you can see that you get all these squares, and it basically divides every body into these squares, so you don't have to check the whole scene. You check only these squares against the body that you're checking for. So yeah, it's very good at finding collisions and doing it fast. However, you can see also that the FPS hasn't really changed. So this just means that the bottleneck of this game right now is not the collision system. So what we're gonna do is we're gonna change this back to the brute force, and I'm gonna ramp up the number of bodies from 50 to about 5. Let's do like maybe start at 200. See if that's any difference. So now the brute force actually has to check 200 squared times. So 200 squared is about isn't it like 40,000, something like that? 40,000 checks, and you can see the FPS has gone down. So now we actually know that okay, the collision detection is now the bottleneck of this game because the FPS went down. So yeah, that's the brute force, and now we're gonna change to sweep and see how that does. And we're back to 165 about. So yeah, the sweep actually covers this quite well, even though we have a lot of bodies, and probably more bodies than I'm gonna use for the game. We'll see. I haven't really finished the idea of the game yet, but let's see how the quad tree works, or how it performs. And it's actually a little bit worse than the sweep right now, but that will change when we ramp up the bodies even more here. So let's change this back to brute force, and let's ramp it up. Let's ramp it up to 500 bodies. So now we're running 500 bodies at brute force. And you can see the FPS goes way down because we need to check like 250,000, I think, something like that. Yeah, where the number of checks goes up very fast. And then let's try the sweep algorithm. So this should improve the FPS by a lot. And yeah, it basically doubles the FPS almost, which is really good, but we can do better. Quad tree. The quad tree, yeah, it stabilizes after a couple of seconds, but yeah, it stabilizes at about 70 FPS for 500 bodies. And this is, I think, way more than we're gonna need. And the nice thing about this is you can ramp up to even more bodies. Let's push this. Let's try 1,000. See how many FPS we get there. And now we're at 1,000 FPS. We're still getting 30 FPS, which is, I guess, acceptable for like old type game, maybe. Yeah, 30 FPS. I mean, it's not. You want to have 60 FPS, but yeah, it actually it works well. However, you wouldn't want to have the FPS rely too much on this, because if you add more calculations and stuff, you don't want to have the FPS go down even further. So, but it's nice to know like the limit of this. All right, I'm just gonna try this again because in the last, well, in my recording here, I just tried to run this with the debug mode, and we're actually gonna run the optimize target here to release fast, and this should increase the FPS by a lot. We'll see how it goes. It takes a bit longer to compile. Yeah, and here we go. We're running at 1,000 bodies and we're back to 165 FPS. So this is with the quad tree algorithm. Let's actually run this with the brute force and see how well that does. Yeah, I should have done this from the start, but I didn't think about it, so. Yeah, it's running at 70 FPS actually. So let's try and wrap it up to like 3,000. Now this should really hurt the brute force. Oh, well, okay, 10, yeah, it's going down. Yeah, this is the brute force. It's actually checking like, how much is this? Like 9 million? Something like that. Checks. Let's try changing to sweep. So sweep is actually sufficient in a lot of cases. It really does really a really nice algorithm that divides the problem really neatly. Okay, yeah, it's also struggling here. Yeah, and but it's really easy to implement, and it works for a lot of cases. However, let's try the quad tree. Yeah, you can see a lot huge difference. And yeah, we can actually run this game no problem. It's 3,000 bodies. I'm not gonna simulate this many bodies, I don't think. But it's nice to know that the engine does have support for anything way beyond what you're ever gonna need. So would be cool to make something like work with this. But as you can see, we can barely fit more things on the screen as it is. So yeah. All right. So yeah, that showcases the different algorithms that is implemented here, and yeah, and really showcases the different FPSs that you get for different amount of bodies. And also now I've also shown that there's a really huge difference between running in debug mode and running in ReleaseFast mode with Zig. So all right, so that's gonna be it for this video. Thank you very much for watching, and see you next time. Bye!